Alright students, this is the big one. Chemistry Vodcast 1.6, this is on dimensional analysis. This is basically how 95% of our problems are going to work this year. That might be a slight exaggeration, but the vast bulk of chemistry problems, as opposed to like physics, use what we call dimensional analysis. So we're going to start off, we're basically going to work through 4 or 5 problems today. So here's our first problem. You've decided that you want to package your barbecue sauce. If you remember the end of the last video, that was our first conversion factor problem, into packets of 1.5 tablespoons each. You've produced 25 liters of sauce. How many packets can you produce? So just like we did in the last video, the first thing you always want to do is write down your given. What gets tricky here is that there are 2 numbers in the problem. How do you know which one's the given? Okay, well, here's the indicator. Everything has each next to it, like the 1.5 teaspoons, that is not your given. That's going to be an inequality. I'll show you that here in a second. So in that case, that means that our 25.0 liters of sauce is our given. So I'm going to make that the given. Your unknown is usually stated at the end. How many packets can you produce? So what I'm looking for at the end is packets. That's going to be my units. So to go back to the other number there, the 1.5 teaspoons, basically what that says is that one packet, okay, that's the each, contains 1.5 tablespoons, that's tablespoons, not teaspoons, sorry about that, of sauce. So that means that equality-wise, one packet equals 1.5 tablespoons. Okay, so that's equality number 1. What that would enable us to do is we can convert packets to tablespoons. I don't have tablespoons to begin with, though. I have liters. So I go to Google, type in tablespoons to milliliters, okay, because milliliters are smaller, and bingo, it comes right up. And you should do this pretty often. I mean, sometimes you've got a textbook or whatever, but I mean, Google's there. I've got no problem with you using it to find out an equality like that, because you still have to work the whole problem. You're just finding out the information you need. So basically, 1 tablespoon then is 14.8 milliliters. So that becomes our second equality. In everything we've done so far, we've had 1 equality. In this problem, we're actually going to have 3, because milliliters is not what I'm given either. I'm given liters, so I need some way to go from milliliters to liters then. Okay, so once we think we have everything, and I've got 3 equalities here, and that's kind of normal for a conversion factor or a dimensional analysis problem, I want to look at those equalities and make sure that I can get from the given to the unknown. Remember, that's what the equalities are for, is that they're supposed to give us a way to get from the given to the unknown. So I can go to packets to tablespoons, tablespoons to milliliters, and then milliliters to liters. So I can get from my given, which is liters, all the way to my unknown, which is packets. Okay, that's what I'm trying to do. That is the whole like central focus point of doing this. So I'm just going to move the problem down here so that we can work the problem up above, so that you can really sort of focus on how to work out the problem, because this is more complicated. So just like in the last unit, we start with our given. That goes in the upper left-hand box of our little railroad track structure that we're going to use. What's going to get more complicated is that I've got 3 conversion factors now, so I don't just have like one place in the railroad track other than the given. I've actually got 3 separate sections past the given. So then the big question comes up, which one do I want to use first? Well, the one you want to use first is the one that has the units of your given in it. So my given is in liters, so I want to use that bottom conversion factor, the 1,000 milliliters equals 1 liter. Okay, and again, we want to put in the bottom of that first box whatever cancels out the given. So since my given's in liters and I want to cancel that out, I'm going to put 1 liter on the bottom, 1,000 milliliters on the top. Okay, so that's conversion factor number 1. That's sort of like what we did in the last section in the simple conversion factors. Here's where it gets a little bit more complicated. So now I have milliliters for units, okay, because what's going to happen here is I've got 25 liters, 1 liter. I can cancel those out, okay. That's what dimensional analysis means, that I'm canceling units. So I cancel the liters, and what I'm left with now is milliliters. That's not what my unknown asks for, though, so I still have more work to do. So then I'm going to take the second equality and I'm going to plug it in the next box. I'm going to put 14.8 milliliters on the bottom, because again, I want to cancel out milliliters, and then I put the 1 tablespoon on top. It has to be the other part of the equality. You can't mix equalities here. And then we're going to cancel out milliliters. Okay, we want to get rid of those now. So now I'm in tablespoons, which is close to what I want, but what I actually need is packets. Okay, so that means I've got one more step of conversions to do. So that's where that initial 1 packet equals 1.5 tablespoons that was given in the problem is going to get plugged in. So on the bottom, I want my 1.5 tablespoons. On the top, I want 1 packet. Okay, and so those are the things then. Now we're going to cancel out tablespoons, and the only thing that's going to be left then is packets. Now that's what we want, right? I mean, the unknown that we're looking for says how many packets can we produce. Okay, so let me get rid of all these equalities real quick. We're going to move those off to the side, and then we're actually going to punch this in the calculator. Now the hard part is, how do we punch all this in the calculator? There's a lot of numbers here. How do I do that? So if you look on the problem here, we're going to put parentheses around the numerator. That's all the stuff on the top, and we're going to do all of that. And then we're going to hit the divide key. We're going to put more parentheses and do everything on the bottom in the denominator. So in your calculator, the way it should look is 25 times parentheses 25 times 1,000 times 1 times 1, close the parentheses, divided by parentheses 1 times 14.8 times 1.5, close parentheses, and then you can hit enter. And this is the answer we get. We get 1126.126126, so obviously getting some repeating stuff going on there. Now again, that's not what we want, so we go back to our given. My given has 3 sig figs, my given of 25.0, and again, that's why it's important you know which numbers you're given. 3 sig figs, so I'm going to round to 3 significant figures here. The 6 is bigger than 5, so that rounds the 2 up to 3, so that means I have 1130 packets of barbecue sauce that I'm going to get out of that. Okay? Now we're going to work several more of these, but that's the basic principle, and if you didn't get that one, you probably want to hit pause at some point, go back and make sure you know where everything came from. So in the second problem, we've got what we call complex units. Okay, so here's the problem. We're driving in Europe, we're moving at 70 miles per hour on our car. We look at the road sign, and since we're in Europe, it's not in miles per hour, it's in kilometers per hour. Okay, so first you would write down 70 miles per hour, but this is the wrong way to write down units. You never want to write down a unit like that in dimensional analysis. You don't want to have a slash and then them all together. You put, if you've got a complex unit like miles per hour or meters per second, you always put one unit on the top and the other unit on the bottom. That's what it means. It means 70 miles in 1 hour. Okay, so that's the way we write it, 70 miles over hours. Now it's going to make our railroad track structure look a little different, because every time we've done one so far, we've only had the given in the top left-hand box, and in this point we're going to have the bottom part of the units in the lower box. So what are we solving for? We're trying to get to kilometers per hour. Okay, so that means that basically the bottom of this one isn't going to change at all. A lot of times it will, but in this case it's not necessary. Okay, so first off, how do we know that that was the 70 miles per hour was my given? Because that's what I was moving at. The 100 kilometers per hour, that's just there to compare. After we find our answer, if we're above 100 kilometers per hour, then we can obviously answer yes, we're speeding. If it's under, then we say no, we're not speeding, or if it's right at. Okay, so how do I know what the equality is? Well, I look up miles to kilometers, again in Google. You could look it up on a formula sheet or something like that. A lot of times it'll be given to you. On a test, you're not going to have to look it up. I'm going to give it to you. Okay, so we're going to look that up, and we see that a mile is equal to about 1.61 kilometers, 1.609, I think it might have said, kilometers. So we're going to take that, and that is our equality. Now, in this case, this is really the only equality we need. All we really have to do is convert miles into kilometers. So the hard part for us here is the setup. So we're going to put our railroad tracks. We put 70 miles on the top, and then on the bottom, that's where the 1 hour goes. It's 70 miles per 1 hour. Okay, so you got to split that complex unit up. If you put them both up top, you're not going to get this right. You're going to screw the whole thing up math-wise. Okay, so the next part then is that we're just going to simply take our equality and plug it in. So I want to cancel out miles. I want to turn miles into kilometers, so I put miles on the bottom. Kilometers then go on the top. Okay, so 1 mile on the bottom, 1.61 kilometers on the top. And then we want to cancel what cancels, in this case miles. And so what's left then is kilometers over hours, unit-wise. I know that before I even work the math. This is what dimensional analysis is all about. You analyze the dimensions, the units. If they're not right, then you didn't set it up right. Okay, so now it's a matter of plugging in the math. We punch it in our calculator. Since everything on the bottom in the denominator is 1, I can really just multiply the stuff on the top. It's just 70 times 1.61. In this case, that comes out to be 112.7 kilometers per hour. Okay, that looks like a pretty reasonable answer, but 1 sig fig, right? Okay, and I know it looks like I jumped the slide there, and I did, so that we've got room to do the sig fig part here. So 112.7 kilometers per hour was our answer there. We look at our initial 70 miles per hour, and we have 1 sig fig. So that means I round it to 1 sig fig. Since what comes after that first 1 is another 1, it doesn't round up, it rounds down. That leaves me with 100 kilometers per hour. Remember that that's still 1 sig fig. Okay? Now here's the thing, you could tell the police officer when he pulls you over, well sure, I was traveling at 112.7 kilometers per hour, but technically if you round that to sig figs, I was really only traveling at 100. Probably not going to work, but you can give it a try. Okay, so let's look at another example of a slightly more complex problem. We're going to work one using traditional English units as opposed to SI units. And this is the sort of thing that you would have to do all the time, that you probably just tried to work out in separate pieces if you did one like this in math class before. So how many milliliters are there in a quart if there are 16 tablespoons in a cup? So that in a cup, that goes back to what we talked about in the last, in the first problem and in the problem on the previous vodcast. When you see the word each or in a, that is an equality. So 1 cup equals 16 tablespoons. We go ahead and write that down. My given in this case is 1 quart. The tricky thing is it doesn't say give you a number for quart, but that's what A means, right? A quart is 1 quart. So that's my given. My unknown then is how many milliliters are there. Okay? So I need to find some way to relate milliliters. Fortunately, we've already worked a problem that related tablespoons to milliliters. So that kind of gets us there really quickly, okay? We go back and look at that previous one, or you could have Googled it again, and it would have told you that 1 tablespoon equals 14.8 milliliters, so we got that. We know that there are 2 cups in a quart, okay? And we know that, given in the problem, is that there are 16 tablespoons in a cup. So we can go from quarts to cups, cups to tablespoons, tablespoons to milliliters, which is what we want. So we can start at quarts, and we can end up in milliliters, and that's exactly what we're trying to do here. Okay, so again, I'm just going to move the problem. Don't let that blow your mind. I'm just trying to make us some room so it's a little bit easier to work the problem. So we're going to start with our given, okay, which is 1 quart in this case, and you don't really have to write out the whole thing. I could have put 1 QT. Okay, that would be quart, not text speed. QT is quart in measurements. Okay, and I want to get rid of that first, so I take the conversion, I take the equality that has quart in it, so 1 quart on the bottom, 2 cups on the top. That's going to let us cancel out quarts, okay, and we'll go back to that in a second. Put 1 cup on the bottom next so I can cancel cups, 16 tablespoons on top. And then our final conversion factor is going to be tablespoons on the bottom, okay, 1 tablespoon in this case, and 14.8 milliliters on the top. Okay, now this is where dimensional analysis comes into play. Sometimes you hear it called the factor label method because you're factoring out the labels or the units. Okay, it means the same thing. And so we're going to go back then and cancel those out. Quarts cancel, cups cancel, tablespoons cancel. The only thing that I'm left with then is going to be milliliters. That's what I want. My question asked me for the answer in milliliters. So that's probably a pretty good indicator that I set everything up right. Okay, and if you're going back and thinking, what does he mean? He keeps saying that these things cancel. Well, if you were doing a problem that had like 2x over x, you would cancel the x's out and you'd be left with 2, right? One thing in the numerator, same thing in the denominator, cancel them out, and that's what we're doing. So we're going to punch these in the calculator. Again, you want to put your parentheses around the top, so parentheses 1 times 2 times 16 times 14.8, close parentheses. Everything on the bottom is a 1, so it's not really quite as important here. We get 473.6 milliliters. We're looking for 1 sig fig though. So 1 sig fig means that we're going to underline the 4. Since the number past the 4 is a 7, that rounds it up, and so that means it's about 500 milliliters. Now, again, that's not entirely accurate because we only had 1 sig fig for a quart. If we'd had 1.00, we could have drug it out a little bit longer. Okay, one more type of problem we want to cover are when we have things that are cubic. The cubic stuff always blows people's minds because it changes the way the conversion factors look, and we'll see how that is here in a second. So this is pretty straightforward for the way it looks at the beginning. My given is 1 cubic meter, okay, meter cubed, that's what cubic meter means. My unknown is liters. I'm not even really that worried about what it is. I mean, it doesn't tell me it's barbecue sauce or grape juice or whatever. It just says how many liters in 1 cubic meter. Okay. Now, and I'm sure someone that's clever probably thought, can I just look that up on Google? You could, but if you're on a test, you're probably not going to have Google. You're going to have to do the math. So how do we get there? Well, we already know that 1 milliliter is equal to 1 cubic centimeter. We've talked about that multiple times in class. Okay? So we already know a relationship between like the cubic length measurement of meter centimeter and the volume measurement of liter. So we got that. And we also know that 100 centimeters equals 1 meter. But here's the problem. We're not talking about straight linear centimeters or straight linear meters. We're talking about cubic. Okay? So here's what we have to do. In algebra, we can do whatever we want to the equation as long as we do it to both sides. So I need cubic meters, and one of my other equalities has cubic centimeters. So what I'm going to do then is cube both sides. So I take that 100 centimeters and cube it. I take my 1 meter and cube it. Now, the 1 meter part is pretty easy. 1 times 1 times 1 is 1. Okay, so that's going to give us 1 cubic meter on one side. On the other side, 100 times 100 times 100 gives us 1 million. So that means we're at 1 million cubic centimeters. Okay, so there's our other conversion. Okay, we can go now from meters cubed to centimeters cubed. We can go from centimeters cubed to milliliters, and then a pretty easy step from milliliters to liters. So 1,000 milliliters equals 1 liter. That then is going to become our third conversion factor. Okay, pretty easy there. And so now, once we get to that point, it's all really just a matter of plugging stuff in. So again, we can go meters cubed to centimeters cubed to milliliters, and then milliliters to liters. So now it's just a matter of plugging everything in. Okay, so I'm going to move stuff around just a little bit to give us a little bit more space to work this problem. So you want to start just like we do every other problem. We're going to write our given in the upper left-hand corner. Okay, and we're going to draw out our railroad tracks. And if you look at this problem, really, there's very little actual math that you couldn't do in your head because everything's in powers of 10. So you could really do the math for this problem in your head. You don't have to, though. So 1 meter cubed, that's our given. The first conversion factor that we want to use is meters cubed canceling out. So we put that on the bottom, then we put 1 million cubic centimeters at the top. Okay, that's going to cancel out meters cubed. We then want to get rid of the centimeters cubed, so 1 centimeter cubed equals 1 milliliter. Okay, that's going to cancel those out. And then the last thing then, okay, that was the one that we sort of always know. That's why that one's in a different color. So then the last thing that we use then is we want to convert milliliters to liters. Okay, so we want to cancel the milliliters. We're going to put 1,000 milliliters on the bottom, 1 liter at the top. We go back and do our dimensional analysis, which remember means cancel out the stuff that cancels. Okay, so meters cubed cancel, centimeters cubed cancel, milliliters cancel. What I'm left with is liters. And so now it's a matter of math. And really the way this problem works out, if you look at the math, is it's 1 million divided by 1,000. That leaves me with 1,000 liters. My given has 1 sig fig, but conveniently so does my answer. Okay, so what are some things to remember when you're doing conversion factors? First thing, always identify the given and the unknown first. The problem won't make any sense if you don't do that. Second thing is to find the conversion factors to get from the given to the unknown. Always cancel your units out. And then you always want to round your answer to the correct number of sig figs. Okay, so if you follow these steps each time, then the problem these problems will work out and you should be able to get them.